Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on January 14th, 2026, about 2 weeks ago. It presents WorldCraft, a novel framework that empowers users to generate executable, visualizable game environments purely from text descriptions, bridging the gap between narrative intent and complex spatial logic. The paper is titled WorldCraft, Agentic Framework to Create Visualizable Worlds via Text. And as we'll see later, the system significantly outperforms commercial code agents like Cursor and state-of-the-art models like Gemini 3 Pro in creating logically consistent scenes. And for those interested in the implementation, the authors have shared their code on GitHub. Figure 1 illustrates the core motivation behind this project. At the top, it depicts the high barriers facing non-experts, playfully called muggles here, who want to create research environments but get stuck learning complex engines like Godot or Unity. The middle section emphasizes that current customization options are often too rigid or code-heavy. In contrast, the bottom section demonstrates the WorldCraft approach, where a user simply inputs a text description, like a luxurious underground bathhouse, and the system instantly renders a complete interactive 2D map. Figure 2 breaks down the architecture into two main modules. On the left, the World Guild handles the cognitive heavy lifting using a team of agents. It starts with semantic enrichment, where the enricher expands simple text into detailed specs, followed by the manager and critic, who iteratively design and verify the layout. Once the plan is finalized, the world scaffold on the right takes over, automatically assembling floors, walls, and objects into a playable Godot environment. While Figure 2 detailed the architecture, Figure 3 outlines the data construction pipeline. It starts on the left, where agents generate initial room layouts using a 12-zone grid system to organize space. Next, in the central refinement phase, a checking agent iteratively improves these drafts to create a verified golden layout. Finally, the right panel shows the Chaos Monkey stage, which intentionally corrupts these perfect scenes to generate thousands of error correction examples. So, with the data pipeline established in Figure 3, Table 1 now quantifies how these design choices impact performance. The top section, labeled Part 1, tests the inference framework. We see that simply adding a critic module to the direct generation baseline significantly boosts the collision-free rate, shown here as CFR. Then, Part 2 at the bottom validates the training strategies. The final row demonstrates that the full method, using correction data, achieves the best results across every metric, confirming that learning from errors is crucial for stable spatial reasoning. While Table 1 focused on internal components, Table 3 compares the full framework against commercial code agents like Cursor and Anti-Gravity. The first two columns track efficiency, specifically the time needed to get a runnable or satisfactory result. We see that while the commercial agents require up to 48 minutes of human debugging, the WorldCraft method completes the task in just over 4 minutes. The final columns confirm that quality is not sacrificed for speed. The method achieves a 92% human win rate, significantly outperforming the manually assisted baselines. Moving from those statistics to visual proof, Figure 7 displays the actual environments generated by WorldCraft across 3 distinct scenarios. The top row reveals the structural layouts produced by the manager agent, showing coherent room divisions and collision-free furniture markers in red. Then, the bottom row presents the final execution. Here, the system has translated those geometric blueprints into fully textured game scenes, populated with specific assets, demonstrating the framework's ability to handle both spatial logic and visual detail. Wrapping up, 2 takeaways stand out. WorldCraft effectively democratizes environment creation, allowing non-experts to build complex AI towns strictly through text. Furthermore, its unique training pipeline demonstrates that teaching models to correct spatial errors is key to generating reliable, executable code. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.